We have a rather full program tonight, so we might as well get started quickly. And I'd like to tell you a small story before we start. Several years ago, there was a mandatory laser safety training for all the principal investigators at Berkeley in the physics department. And I went to this event, and I was sitting next to a distinguished person, and for about an hour and a half into the proceedings, I realized that if not my neighbor, we wouldn't have to suffer through this laser safety training. Let me introduce to you Professor Charles Townes, who invented the laser. And in fact, think about it, without the laser, there wouldn't have been laser spectroscopy. Professor Townes.
Well, it's awfully good to be here with you, and all these people are doing so much good work with lasers and so on. Now, how did laser happen? Well, I'd been working with microwaves. I wanted to get to shorter and shorter waves. And the Navy wanted to get shorter waves, and they knew that, so they asked me to form a national committee to see how to get down to shorter waves shorter than about half a centimeter. That was the shortest we could get at that time. So we formed a committee of important scientists and engineers. We traveled all around the country asking people, have any ideas? We didn't find any. So we gathered together to write a report saying we're sorry we couldn't find any results. And as it was being typed up, I sat up on a park bench and said, gee, that's too bad we couldn't find the answers. Of course, I said, well, of course, molecules produce short wavelengths, but they can't amplify. The total power is limited by temperature. Oh, wait a minute, they don't have to be controlled by temperature. Oh, hey, we can get more in the upper level than the lower level. That's not temperature controlled. Oh, well, I pulled out my notebook and I wrote down a few notes on it. But I didn't tell anybody about it, so we wrote a report, so sorry we couldn't have any answers. Well, I went back and thought, well, I had microwave equipment. Maybe I should try to use molecules to amplify microwaves first and see if it works there. So I started doing it, and Jim Gordon, a student who worked on it, and now Professor Cush, who was chairman of the department, Professor Robbie, who was previous chairman of the department, both of whom had Nobel Prizes, so they weren't stupid. They came in my laboratory where we were working and said, look, that's not going to work. We know it's not going to work. You've got to stop. You're wasting the department's money. You've got to stop. Well, fortunately, I was an associate professor by then, so they couldn't fire me just for being stupid. They could fire me if I did something morally wrong, but not just for being stupid. So I was able to continue, and Jim Gordon, fortunately, was brave enough to continue as a student, and we worked on it. And 3 or 4 months later, we had it working. Whoa! Nobody paid much attention to it until it got working. And people would come by and say, oh, yeah, that's an interesting idea. Once it got working, then a lot of people jumped into the field. And there are lots of works on lasers, and lasers of all kinds were invented by a variety of people. Well, now, of course, in the long run, I wanted to get down to shorter wavelengths. That was my primary idea, to try to find oscillators at shorter wavelengths, so I had to do spectroscopy, high-resolution spectroscopy at shorter wavelengths. And I thought about it, and I talked with Art Charlow, who was a postdoc with me at the time, and we worked on it. And we wrote a paper about how we could get down into the infrared and maybe the visible region even, using molecules to amplify it. Oh boy, could that be done? Well, we wrote a paper saying we thought it could be done. And I kept thinking about how to do it, but Ted Mayman was the first to do it. He did it with Ruby. He used pulses. Now, I had thought about Ruby, and I calculated, and I said I couldn't get enough energy to pump it up have it excited enough to do it. But with a pulse, he could get enough energy. I hadn't thought of using pulses, so he used a pulse, and he did. And that was the first laser with a pulse. Ted Mayman. Well, after that, then a lot of people jumped into the field and worked on it, and so did I. And so lots of lasers have been produced, and they come in all varieties now. I'm just thankful for all the great people who contributed to it and done so much. Thankful for all of you who are here, and I'm so glad it's useful. I recognize it would be very useful scientifically. I recognize it has some important applications. I never realized it'd be good for medicine, but I did see various applications, various technical applications for it, and of course it's been very widely applicable. And about 10 Nobel Prizes have been given for people using lasers, using laser technology and so on to do new things. There have been a lot of interesting new things, and I'm just very grateful for all the people who've contributed and done so much with it. Thank you very much for all of you. And I must say, I have to think about how do new ideas come about. Well, of course, I worked on it, and I worked on it with a committee organized paid for by the Navy and so on. We didn't find any answers, but as a result of for not finding answers, I worried about it. I thought, well, hey, wait a minute. Of course, molecules can, in principle, do this, but they're limited by temperature. Their power is limited by temperature. Oh, well, they don't have to obey temperature. And wait a minute, maybe we can do it. Well, it took quite a while to do it. And as I say, I first did it with a Mesa microwave amplification. Jim Gordon was building it. And famous professors Cush and Robbie said, oh, that's not going to work. You know it's not going to work. You've got to stop. You're wasting the department's money. You've got to stop. Well, it's good we've got enough independence in universities, particularly with people who have tenure. Got enough independence they can't fire just for being stupid. And so I was stupid enough to continue. And 3 or 4 months later, we had it working. Wow. Wow, and then a lot of people jumped into the field. Now, to get down to shorter wavelengths, I wanted to do that, but it seemed difficult, but I wanted to do it. And it was with Art Charlow, my postdoc, that we figured out ways of doing it. And eventually, of course, many people did it. I didn't build the first one, but many other people contributed, and I'm very thankful that they have. Thank all of you for your excellent work in this field, and very best wishes.